Welcome to ClusterControl's Kubernetes Database Operator Management. In this demo, I'll show you how to work with Kubernetes database operator deployments with ClusterControl, from connecting to your Kubernetes environment using GitOps workflows to installing database operators, deploy databases, taking backups, and more. First, we need to connect our Kubernetes environment to ClusterControl. Let's enter the management panel by clicking Kubernetes in the side nav panel. After clicking environments from the Kubernetes overview panel, click the Connect Environment button to begin the workflow. Enter the environment name, ClusterControl's host and port, as well as the agent namespace and preferred chart version. If you want to incorporate GitOps workflow into the process, you can do so by toggling the Enable GitOps box here. We'll go ahead and do that. Now, provide the details for the GitHub repository that will store your YAML manifests, its URL, base path, and branch. Authenticate using your GitHub personal access token. This will allow ClusterControl to push config changes automatically. Let's move on to Argo CD. Copy and execute the kubectl command in your terminal to install Argo CD with a production-ready setup. I'm using the Kubernetes terminal for easier access to the Kubernetes resources. We can see that the Argo CD resources are getting up and running. Argo CD is successfully deployed, so we can proceed to the next step, applying agent manifests to install it inside your Kubernetes cluster. You can choose any option, download YAML manifests or execute inline kubectl command. I'll copy the inline command and execute it through the terminal. The environment is now configured and deployed. Let's wait till the environment agent becomes active. Now that the environment is active, you can hover over the GitOps status to get the details. Let's take a look at the pending GitHub pull request to merge and complete the environment setup. Now let's go back to the ClusterControl UI to check the GitOps status. Now it's ready. Next, we'll create a new namespace in our cluster by entering the namespace panel, clicking the Create Namespace button, and selecting its environment and giving it a name. You can see the YAML that you can use for manual deployment from the terminal. The pull request for the namespace deployment was created, so we'll go review and merge it. Let's check what is being created, a namespace and 2 role bindings. Now let's merge the pull request and wait for it to propagate to ClusterControl. Be patient, it can take a minute or two. The namespace is now successfully created. Environment and namespace setup. Let's deploy our first operator. Enter the operator panel, click the Deploy Operator button, and begin by selecting the environment, namespace, and operator we want to deploy. The CNPG operator for Postgres databases in this case, and its version. Next, we can review and modify any configuration parameters as needed. You can check the defaults to see what will be included out of the box. You can also modify the settings in YAML format. Let's create a deployment request. Review its configuration details, check its YAML, and then click Deploy Operator. Pull request created. Let's merge it and wait for it to propagate as we did with the others. Let's wait for a minute for the operator to finish deploying. The operator is now successfully deployed. Let's perform the same process on the MoCo operator for MySQL databases. As before, we'll pass the same set of inputs. Select the MoCo operator instead. Let's review the default parameters for the operator. And start deployment. The pull request was successfully created, so let's merge it. As you may have noticed in the creation wizard, the workflow will create two pull requests, one for the operator and one for its Cert-manager dependency. So let's merge that pull request as well to finalize the MoCo deployment. Now you can see that both operators are ready to go. Let's deploy some databases. For that, we'll go to the clusters panel and select the environment and operator, and enter the cluster and select its namespace and the number of nodes to deploy. You can also select configure templates to standardize and increase the speed of database deployments. Let's first look at the database configuration template and select a small template. Then we'll select a resource configuration template, storage class, and whether we need public exposure or the database through its node port or load balancer service. Let's deploy the database. As in previous steps, we can review the YAML template to validate everything. We now have an operational 3-node Postgres cluster running. Let's take a look at its details where we can see the connection and credential information. Okay, time to create a backup schedule for our S3 or S3 compatible storage. First, we'll grab our credentials. You can import or create credentials. We'll import S3 credentials we've already established. Next, we'll configure the backup schedule. Click the Configuration Schedule button and begin by entering the destination credentials and bucket name. You can also add a specific bucket location to send your backups. Lastly, we'll define the schedule, retention policy, preview the configuration, and set the schedule. The backup schedule is created and running. I'll now follow the same process for MySQL, and I'll speed up the footage just a little bit so that we can get through it quickly. We'll now have a 3-node Postgres cluster running alongside a MySQL replication cluster we deployed following the exact same process. Remember those configuration templates? Let's review them by going to the Settings panel and selecting Resource Templates and clicking View to expose their full YAML definition. You can edit the defaults, but can also create a custom one from scratch by providing a template name, CPU and memory requests and limits, plus persistent storage volume size. Click Create, and here we go, another template created. The same can be done for operator templates. We'll create one for Moco to demonstrate what it looks like. You can provide any custom parameters or change default ones. And finally, let's stay with our MySQL deployment to check our logs. As you can see, you can search through the logs for any instance or container and filter them to narrow your search. That's a wrap. Visit severalnines.com to see how you can implement ClusterControl to provide a unified experience for Kubernetes-based and traditional environments.